First part, explain what is meant by a radian. So if they ask you for a radian, the radian is the same answer. Angle subtended at the center of the circle when the length of the arc is equal to the radius. Because we actually obtain it from this formula. Theta is S over R. So when S equals to R, your theta will be 1. That's what it means by 1 radian or a radian. Why one complete revolution is equivalent to an angular displacement of 2 pi radian? Now, to prove that one revolution is 2 pi radians, we can start back again with the formula for the angle in radians, theta equals to S over R. So for one complete revolution, remember S here represents the length of the arc. So for one complete revolution, the length will be your circumference, which is 2 pi R. So you substitute S as 2 pi R, then the R means continue to write it at the bottom, then you can cancel the R and you get 2 pi radians. So that is the derivation of why one revolution is 2 pi radians. Now, if you look at this question, right, they gave you that this is an elastic cord. So what is the elastic cord referring to? Like a rubber band, like a rubber cord, that's an elastic cord. Now, there is actually some what do you call it, implication of using in an elastic cord. The implication is an elastic cord will stretch when a tension is applied. So actually it's good for us that they use an elastic cord, because if you see that there's no extension, that means there's no tension. But if there's an extension, we know there'll be a tension. So this is good news for us. Now the other, the opposite of elastic cord, right, is not inelastic cord, by the way. The opposite of elastic cord is called an inextensible cord. So inextensible cord, that one is a bit harder. You know why? Whether or not there's a tension, there will still be no extension. So by looking at the length of the string, we won't be able to tell whether there's a tension or not. But elastic cord can. Do you understand? So the first part they gave you was the original length is 13 centimeters. That's what they told me. At the same time, they also told me that when you hang a 5 Newton mass there, the cord extends to 14.8. Now, this part is actually in equilibrium. That means imagine, right, the cord, you just add a mass to it, it will stretch a little and stop. So they're referring to that. It stretches a little and stops. At that time, the total length is 14.8. That's all. Now, the next part is when you actually rotate it at constant angular speed. So when you're rotating at constant angular speed, they gave you one specific situation, which is when the cord is vertical and above point C. So if you look at the next diagram, so this is the C, which is the center of the circle. The cord is vertically above it. Okay, the cord is vertically above it. So they told you that the length is the unextended length, 13 centimeters. That means imagine, right, the stone goes in a circle like this. Imagine it goes a circle like this. When it reaches the highest point here, the length is 13 centimeters. That's what they're trying to tell you. So from this information, find the angular speed of the cord and the mass. Now, the thing is, for circular motion, the correct approach, right, to solve is to always try to solve using the simplest formula. Like some people say, oh, angular speed is omega equals to 2 pi over period or 2 pi f. Yes, you can try that first, but unfortunately, period and frequency were not given. So, too bad lah. Then we try the next more difficult equation, which you should try what? Resolution of forces. Because all circular motion needs a centripetal force, which I told you is a net force. Therefore, you have to find the forces acting and find the net force. That's why I always tell you to try to approach circular motion questions using resolution of forces, because you will need to find the net force. And because centripetal force is your net force. So what are the forces acting on the stone at the highest point? Now, definitely there's a weight. But my question is there a tension? Because normally your tension will be pulling the mass down or not. But in this case, got tension or not? No. Why? Because the length is 13 centimeters, which is equivalent to its unextended length. So there's no extension, means no tension. So this one is quite straightforward. In other words, the only force acting on the mass is the weight. So therefore, that becomes your resultant force. So your weight is your resultant force. It causes a circular motion. So therefore, the resultant force is mr omega squared. Now, if this weight caused the stone to fall downwards, then we can use mg equals to ma lah. But here, it caused the stone to move in a circle, so it's mg equals mr omega squared. So that way, you can cancel 1m, and you can find omega already lah, because you know g and you know r. And what is the radius of the circle? It is the length of the chord, 13 centimeters. And then you'll be able to find the omega. Right, the next part tells you that the chord and the mass rotate so that the chord is vertically below C. So now imagine the chord goes to the bottom here, which is here. So you want to find the length of the chord, assuming it obeys Hooke's law. So once again, we would try to solve by resolution of forces. Now, if now, right, you draw the free body diagram, there will be a tension because there's a length L, not necessary 13 centimeters. So some people ask me how I know there's a tension or not. Assuming there is lah, because I wouldn't know what is the length here lah. So let's assume there's a tension here and the length L is longer than 13 centimeters. And then that will be tension upwards and then there'll be a weight downwards. Now, as usual, we would find out the resultant force, but how do I decide to take tension minus weight or weight minus tension? Which do you think will be bigger, tension or weight? Tension. Because you know why? The centripetal force, which is the force acting towards the center of the circle, is your resultant force. So if you know your resultant force is pointing up to C, that means tension must be bigger than weight. Because if weight is bigger than tension, then your resultant force will be downwards, won't be pointing to C anymore. So your tension has to be bigger than your weight. That's why I will take tension minus the weight equals to mr omega squared. Now the good news is they did tell me it's moving with constant angular speed. So whatever angular speed I calculated for the top, I can actually use it for the bottom. But there are a few things that you need to know how to solve. So I'm going to start off with the equation first. T minus mg, that becomes your net force or your resultant force or your centripetal force equals to mr omega squared. Now how to find tension? Now they did give you a clue. The tension can get from this Hooke's law because it obeys Hooke's law. So remember Hooke's law, force equals to kx or tension equals to kx. So your tension here equals to kx. Now what is my k? I don't know. But my x, right, I can take the total length of the chord minus its original length 13 centimeters, right now. So L minus 0.13 will be the extension. You agree now? So minus the weight, which is 5 newtons, equals to M. Now, how to get the M is weight over 9.81 now, because they give you the weight is 5 newtons here. So you divide by 9.81, you get the mass. The radius of the circle is L, because this is your length of your chord, which becomes your radius of the circle. Omega can use back. So you'll notice you're almost there. To find the L, you basically need to solve the K first. Then you can solve the L. But how to find the K though? Now remember, there was one piece of information that we haven't used yet, which is this part. When you hung the 5 newtons mass, it extended to 14.8 centimeters and came to rest. We need to use this piece of information to find the K. Why? Because when the mass is at rest here, tension equals to weight. So tension equals to kx because of Hooke's law. What is the extension? 14.8 minus the original length 13 centimeters, so 1.8 centimeters equals to 5 newtons the weight, and you get the K. After you get the K, you can basically substitute inside here and you can solve for the L. But at first you will get it in meters, then later you will convert it to centimeters, then you get the answer. Alright, we're going to start off with part B. Now they gave you a stone with a weight of 3 newtons is fixed using glue to a rigid rod. So there's this glue connection between the stone and the rod. And what happens is you rotate it in a vertical circle. So you can imagine it's moving like this. And as you slowly increase the angular speed, from 0, what happens is at a certain speed, the glue snaps. So the glue fixing the stone snaps when the tension is 18 newtons. So for the position of the stone where the glue snaps, mark with the letter S the position of the stone. Now remember, the free body diagram that you want to draw is actually for the stone. So what are the forces acting on the stone? Will be the weight of the stone and the tension exerted by the glue on the stone. So therefore, I told you guys before, for a vertical circle, where is the tension the biggest? At the bottom. So therefore, the glue will actually snap first at the bottom. So what you need to do is label the lowest point here as S. All right. Now you don't have to draw a stone like me. You can just label on the circle here S lah. But I drew a stone to help you understand. All right. Next part. Calculate the angular speed of the stone. So since they gave you the tension at that time, which is 18 newtons, and let's resolve. So we said that the tension has to be bigger than your weight. So tension minus weight equals to centripetal force, mr omega squared. Since you want to find omega, that's why I use mr omega squared. So some people ask me why I never use mv squared over r, because they want to find angular speed lah. If they ask you to find the linear speed, then I would use mv squared over r. Angular speed is mr omega squared. Okay, now I use that to find omega. So substitute your tension and your weight. M is just your weight over 9.81. R is the length of the cord here, all right, or the rod here, and then you can find the omega. Okay, so for this question, you have this roller coaster that is going in one loop lah. So imagine the passengers enter the loop here, go one round, and come back out again. So the loop has this radius, and the passenger is 60 kg, traveling at 12 meters per second. Assume that the frictional force may be neglected. So for the passenger at the highest point, find the centripetal acceleration. Now, they only want centripetal acceleration. Do not confuse with centripetal force. So centripetal acceleration has two formulas. They have two formulas, V squared over R or R omega squared. So which formula to use? Do you realize they gave you 12 meters per second? Is that V or omega? It's V, right? So therefore, you use A equals to V squared over R, straightforward. So 12 squared over the radius 7 meters. So that is your centripetal acceleration. Second part, find the force that the seat exerts on the passenger. Now, many students mistakenly think they want centripetal force. They are not asking for centripetal force. If they wanted centripetal force, they would have said centripetal force. They wouldn't say the force that the seat exerts on the passenger. The force that the seat exerts on the passenger is actually called normal reaction force. They want to find normal reaction force, not centripetal force. So it's not so straightforward. Top find the centripetal acceleration, then times the mass get centripetal force here. They don't want. They want normal reaction force. So you have to draw a free body diagram at the top here. So what are the forces acting on this passenger? Two forces, normal and weight. Now, you remember, right, your normal will be downwards. Of course, everybody knows the weight is downwards. But why is normal reaction force downwards? Because if the passenger's butt is sticking onto the seat, that means it's pushing up on the seat. His butt is pushing up on the seat. So according to Newton's third law, the seat will push back down on him. That's the normal reaction force. So your normal reaction force plus your weight equals to mv squared over r. This is your working here. So your normal will be mv squared over r minus mg. But the good news is v squared over r you calculated as 20.6. So no need to calculate separately. So 60 times v squared over r minus mg. That will become your normal reaction force. Part 2, the passenger now moves round and descends to the bottom of the loop. So let's assume that the passenger now goes down. What is the change in potential energy? So that is straightforward, mgh. But don't forget, the change in height from top to bottom is 14 meters, 7 plus 7. So it's just mgh. So next part, find the speed of the passenger on leaving the loop. So when it goes from top to bottom, this is the GPE it lost. What is the speed when it reaches here? So don't forget, when you move from top to bottom, it's going to lose GPE, but it's going to gain what energy, guys? KE. So therefore, it will be loss in GPE equals to gain in kinetic energy. But be careful, right? When you're doing gain in KE, you must take the KE at the bottom, which is the higher KE, minus the KE at the top. Many students, you know what they do? They do 8240 equals to half mv squared, without having half mv squared minus 12 squared. Because they're assuming at the top has no KE. Then only it will be 8240 equals half mv squared. But don't forget, you have a speed here, 12 meters per second, you got KE here. So the KE here minus the KE here equals to mgh. Then only you can get 20.5. So Part 3. Operators of the ride must ensure that the speed at which the passengers enter the loop is above a certain minimum value. Suggest a reason for this. So what they're saying is, if you are sitting in this roller coaster, usually before you enter the loop to go upside down, right, you actually like bring you from a very high place, you fall down very quickly, then you enter the loop very fast, right? Then only you will come out. Now, do you ever enter the loop slowly, and then finish it very slowly and come out? No, right? Actually, right, people say, why must be fast? Is it to make it more fun? Actually, not really. It's actually to make it safer. The faster you enter the loop, the safer it is for you. The less likely you are to fall off the seat at the highest point. Because you're very afraid at the upside down place you will fall down, right? If you're moving fast enough, you never fall down. So you must be moving fast enough here, then only you won't fall. So therefore, you must enter the loop fast enough. That's what they're trying to say. You must enter the loop above a certain minimum speed. You must enter fast enough. Then only you will be safe. Why? So again, right, let's look at the forces acting at the top here, because this is the dangerous part. When you are here, right, remember the normal plus weight equals to mv squared over r? So your normal is mv squared over r minus mg. If you are too slow, as in your v at the top here is too small, then your mv squared over r minus mg gets 0 means, normal 0 means your butt not touching the seat. That means you are falling down. You understand? So no matter what, your butt must touch the seat. The harder it pushes up on the seat, means you are safer. Do you understand? It means you're sticking to the seat. So you want the normal to be more than 0. So mv squared over r must be bigger than mg. That means you must move fast enough. Then only your normal is not 0. Do you understand? So because you have a minimum speed at the top, therefore you also need a minimum speed at the bottom due to conservation of energy. Because the difference in KE here will give you mgh. Mgh is fixed. Since you have a minimum speed here, you must also have a minimum speed here. Do you understand? Because it's half mv squared here minus half mv squared here equals to a fixed value 8240. Okay? So the answer is here. You write down at the top, this is your equation. So in order for a passenger not to fall, n must be more than 0. Therefore, there must be a minimum speed at the top because this must be bigger than this. So since the speed at the bottom determines the speed at the top due to conservation of energy, there must also be a minimum speed at the bottom. So you copy this part for your answer.
That's all for today's video. If you're interested in more genuine sharing by other geniuses, please subscribe to our channel and don't forget to turn on the notification bell, ding dong. Also, if you're struggling with 1 or 2 past year questions and the mark scheme just doesn't seem to help, Genie has got you covered. Feel free to let us know what question it is by filling in the Google form linked in the description below. GenieUs Hub will get genius teachers to fulfill your request for the solution. Genie will see you next time. Bye-bye.